Alright, good day and welcome. Mr. Simons here. So I'm just looking at the basic class test. Can be assignment for 50 marks, 25 marks exponents, 25 marks surds. So I assume you've worked through the first 15 lessons. Now I'm just putting all those things together in test format. So first page, you can pause, write down the problems, try to answer them yourselves. There are 2 slides with work on, so this is the first 25 marks on exponents. But there, take note, we'll always test one multiplication and division sum. Then we'll test one that has plus and minus, where we test common factor. Here again, plus and minus with division. Exponential equation, easier one, more complex one. So generally we set up the test from easy to difficult to the end. So I hope you paused and you're solving the problems. Let's look at the second slide. The second slide, yes, 25 marks on surds. There testing law 4 of surds. There we have a square root. Trinomial given normally becomes a perfect square. There multiplying, testing law 1. Testing addition and subtraction of surds by making them like terms. Testing distributive law. Testing simplification of a fraction. There, testing multiplication or finding products. And again, exponential equation in there. Right, so you can pause, write down the problems, attempt to do it. It's a little bit more complex here and there, but end of the day, you should be able to practice, make note of your errors, redo your errors in such a way that you practice the error out. As I said, I normally practice or re-practice 5 times doing the same problem. So let's look at the solution. So 1.1, we have 25n minus 2 times 24n plus 1 times 5 negative 1. Simply said, simplify 75n minus 2 times 9n plus 2, 6 marks. So first and foremost, in this multiplication and division only, we're always first going to find prime bases. So prime base for 25, 5 to the power 25. Or 25 equals shift factor on your calculator. 27, 3 to the power 3, that stays as appears. 75 is 3 times 5 squared, give me 75. And 9 is 3 to the power 2. So 2 marks for top line, bottom line, correctly writing as prime bases. Right, now we're going to test your multiplication. So 2 times n gives me 2n. 2 times negative 2 gives me negative 4. Please, this is where you'll make errors. 20 years teaching, learners will go multiply 2 times n, but they forget the 2 must also be multiplied by the negative 2. So both of them, please. There, 3 times n, 3n, 3 times 1, plus 3, that says minus 1. 3 there, invisible 1, so 1 times anything stays the same, so therefore it becomes 3n minus 2. 5, 2 times n gives me 2n, 2 times negative 2 gives me negative 4, 2 times n gives me 2n, 2 times 2 gives me plus 4. So 2 marks there for correct multiplication, top line, bottom line. Alright, so there law 3 and law 4 of exponents done. If you're not sure of this, I've done a lesson previously on multiplication and division of exponents. Right, so now start always technically with a smaller base 3. Anything on top is written as it appears. If I come below the division line, I change the sign of the exponents because I have to subtract exponents. So that becomes 3, 3n plus 3. There plus n becomes minus n, minus 2 becomes plus 2. Plus 2n becomes minus 2n, plus 4 becomes minus 4. And those are my 3 base 3's. Look at base 5. It becomes 2n minus 4. Right, minus 1. So everything on top written as it appears. Come below the division line, I change the sign because I'm subtracting, so that becomes minus 2n plus 4. 3n minus 2n gives me n minus n. All the n's cancel. 3 plus 2 would give me 5. 5 minus 4 gives me 1. There 2n minus 2n cancels. Minus 4 minus 1 gives me negative 5. Plus 4 would give me negative 1. So that gives me 5 to the power negative 1. Alright, and we're not allowed to have a negative exponent in our final answer. So 3 stays on top and 5 negative 1 I take to the bottom, and it becomes 5 to the power 1. Right, so 1 mark there for simplification and 1 mark writing as positive exponents make up your 6 marks. Right, let's look at the second. Alright, now problem number 2. See, they have 2x plus 2 minus 2x plus 1. Should see there's a minus sign separating the two exponents. Therefore, I'm going to look for a common factor, right? So if I take out 2 to the power x, I'm left with 2 to the power 2 minus 2 to the power 1. Alright? Not 2, not 1, but 2 to the power 2. Don't forget the base, né? That's where you'll make errors. Right, so 2 squared would give me 4. 2 to the power 1, 2. 4 minus 2 becomes 2. Bases are the same. So remember, there's an invisible 1 there, so that becomes 2x plus 1. So 1 mark for taking out the common factor, another mark for simplification there, and 1 mark for the final answer. Right, if we look at 1.3, I have 9 to the power n minus 3 to the power n plus 2 plus 20. I had to change it, there was an error. 3 to the power n minus 4. So this one is slightly different from the one you see in 1.3. So there 3 to the power 2 is a prime base. There I can split, so I write that as 3 to the power 2 times 3 to the power n, and 20 simply stays. So 2 times n would give me 2n. 3 squared gives me negative 9 times 3 to the power n plus 20, and I have 3n minus 4. So 2n is 3 to the power n times 3 to the power n. N plus n, remember when we multiply and the bases are the same, we add exponents, so n plus n would give me 2n. Right, factors of 20 that add up to 9. Minus 5 times minus 4 would give me positive 20, but negative 5, negative 4 would give me negative 9. So there, 3n minus 5, 3n minus 4, those two would cancel, and I'm left with 3 to the power n minus 5. So there, 1 mark for writing as a prime base, another mark for splitting that 2. Then 1 mark for the top line, correct multiplication and simplification, second mark. 2 marks for factorization, 1 mark for cancellation, and another mark for the correct answer. So that's for 1.3. So hope you understand so far. Let's look at the next set of problems. Right, so in 1.4 we have an exponential equation. 2x to the power 1 over 4 equals 10. So I have to solve for x. So to solve for x, I'm first going to divide by 2. 10 divided by 2 would give me 5. So I have x a quarter equal to 5. Now to solve for x, that must read x to the power 1. So to make a quarter 1, I'm going to multiply it by its inverse, which is 4. If I do on one side, I must do on the other side. So there 1 over 4 times 4 becomes x to the power 1. And 5 to the power 4 would give me 625. Right, and 1.5, more complex exponential equation. I have 2 to the power 2x plus 4 plus 31 times 2 to the power x equal 2. So first I'm going to bring 2 over, and it gives me negative 2. There, if I split, I have 2 to the power 2x, the same 2 to the power 4. Plus 31 times 2 to the power x, minus the 2 that was brought over. 2 to the power 4 gives me 16. So that simply becomes 16 times 2 to the power x. That still stays the same, and that stays the same. Right, now we have to factorize. Generally, how we see if we're factorizing trinomial, you see 2x and x there. X is half of that, so if I factorize here, I've left it as 16 times 2 to the power x times 2 to the power x. If the bases are the same, we add exponents, so x plus x gives me 2x, but you see that's the x that's in the middle. Factors of 2 can only be 2 times 1, so positive 2 times negative 1 gives me negative 2. But if I multiply now, 2 times 16 would give me 32, minus 1 gives me the plus 31. So from there now, using the zero factor law, you can say 16 times 2 to the power x minus 1 equals 0. If I take 1 over, it becomes positive 1. I always divide by the coefficient of 2 to the power x, which gives me 16. There 2 to the power x, if I take plus 2 across, becomes negative 2. This side here, I have no solution because this base is negative and that one is positive, right? And you don't do logs, etc. So for now, no solution. Right, 2 to the power x equal 1 over, if I write the bases the same, 2 to the power 4. So with exponential equations, the bases must be the same to solve the exponents, right? Take 2 to the power 4 up. If it's positive here, comes negative on top. So 2 to the power x equal 2 to the power negative 4. And therefore, x equal negative 4. Right, so hope you follow. So for 5 marks here, 1 mark for writing the equation standard form, 1 mark for factorization, 1 mark here for writing the base the same, another mark for no solution, the last mark there, x equal negative 4. Right, now let's look at the set of surds and solve them. Right, so 1.1, we're simplifying. I have fourth root, square root 256. Now there's two ways to solve it. You can say square root of 256 gives me 16. And the fourth root of 16, remember 16 is 2 to the power 4. So the fourth root of 16 would simply give me 2. Or, applying the laws of surds, I can multiply the values in front of the surds. So 4 times the 2. And then 256 can be expressed as 2 to the power 8. That becomes now 8 divided by the 8 there, which gives me 1. And 2 to the power 1 equals 2. So 1 mark for the first step, 1 mark for the answer. 1.2 appears a lot, it's not really difficult. Give you one long square root with a quadratic equation at the bottom. Generally, I'm going to make it a perfect square. So there x squared becomes x times x, y squared simply y times y. If I say 1xy plus 1xy gives me 2xy. Because the brackets are the same, I can write it as x plus y all squared. And square root and square cancel, so I'm left with x plus y. So 1 mark for factorization, another mark for writing it as a perfect square, and another mark for simplification. So that is your 3 marks. Right, next. 1.3, we have fifth root times fifth root. So that is generally first law of surds. In the bracket, 27a cubed times 9a squared. So if I have fifth root times a fifth root, I can write them all under one radical sign and say fifth root. Right? 27a cubed times the 9a squared goes there. 1 mark. 27 times 9 gives me 243. A to the power 3 times a squared. What's 3 plus 2 gives me 5. 243 can be expressed as 3 to the power 5. So 5 divided by 5 gives me 1. 5 divided by 5 gives me 1. And that becomes 3a. So 1. And your third mark for the final answer. 1.4, when we add and subtract surds, we have to make them like terms. Right? So like terms meaning they have the same value under the radical sign, same exponents, etc. So 432. Right, we need to know all our perfect squares up to 169. So therefore 32 becomes 144 times 3. Once I have the first times 3, I know the rest all are times 3. So 147, 49 times 3 gives me 147. 192, 64 times 3 gives me 192. x6 simply stays. Square root of 144, 12. x6 divided by the 2 from the square root, 6 divided by 2, x cubed. Square root 49 would give me negative 7. x6, 6 divided by square root, or the 2 of the square root, gives me x cubed. Square root 64 would become plus 8. x6 divided by 2 gives me x cubed. 3 prime number, so square root of 3 irrational, square root 3, square root 3. So you should see I have like terms. Now I can add the coefficients. 12 plus 8 gives me 20. 20 minus 7 would give me 13. X cubed simply stays and square root 3. So 1 mark there for finding multiplication by 3, 2 marks for simplification, and 1 mark for the final answer. Right, let's look at the next two problems. Right, in 1.5, now we have a surd multiplied by 2 surds inside, distributive law. So there's no plus or minus, therefore that's multiplication. So 3 square root 2 times square root 2. Positive times negative stays negative. 3 square root 2 times square root 288. So 3 times 1 stays 3. Square root 2 times square root 2 which simply becomes 2. Minus the 3 square root 2 times square root 288. I place under 1 square root and I say 2 times 288, which gives me 576. So 3 times 2 then gives me 6. Minus 3 times square root of 576 is 24. So 6 minus 3 times 24 is 72, gives me negative 66. So 2 marks there for correct multiplication for each one. And then a third mark for simplification. Right, in 1.6, as you can see there in blue, everything is mainly square root 5. So can I write 20 in terms of square root 5? So the perfect square in 20 is 4. 4 times 5 plus my square root 5. 4 square root 5 minus 5 to the power half. Remember with a half, 1 goes inside, 2 goes outside. So that simply becomes square root 5. So 4 square root 5, square root of 4 becomes 2 square root 5 plus square root 5, and therefore minus 1. 4 square root 5 minus 1 square root 5 gives me 3 square root 5. So 2 plus 1, 3 square root 5 divided by 3 square root 5 equal 1. Right? Hope you understand. Right? 1.7. Now we have 2 plus 2 square root 5 all squared minus 3 square root 2 square root 5 plus square root 2. Very important, I have two terms, binomial, squared, so don't forget the middle term. So 2 times 2 gives me 4. For middle term, 2 times 2 is 4, times 2 gives me 8, square root 5. For the term at the end, 2 times 2 gives me 4, square root 5 times square root 5, 5. Negative times positive, negative. 3 times 1, 3, and that becomes square root 2 times 5, all under 1 square root because it's the same. Negative times positive gives me negative. 3 times 1 is 3, and square root 2 times square root 2 simply stays 2. So this stays 4 plus 8 square root 5 plus 4 times 5 is 20. 2 times 5, I assume you know, is 10, and negative 3 times 2 gives me negative 6. 4 plus 20 gives me 24, minus 6 gives me 18. 8 square root 5, don't have a partner, so that stays. Minus 3 square root 10, no other like term, so that stays. So there, 1 mark for correctly multiplying out that 3, another mark for correctly multiplying out that part. Then here, 1 mark for simplification of 18, and another mark for understanding that that 2 is the same. Alright, last problem. So 1.8, we have 4 equal half x minus 3, exponential equation. Right, because I see 2 there, I'm going to express 4 as base 2. So 4 is 2 to the power 2. If I take 2 up there, it becomes 2 positive 1, so it becomes 2 negative 1 on top, x minus 3. Right, so bases are the same, so I can drop the exponent, so that stays 2. Negative 1 times x is negative x. Negative 1 times negative 3 becomes positive 3. If I take x to the other side, it becomes positive. 3 stays, and if I bring 2 over, it becomes negative 2. And 3 minus 2 then equal 1. Right, so I hope you understand. I hope you thoroughly enjoy the lesson. Continue practicing. Wish you nothing but the best. Bye.